All right, let's jump right into this explainer. Today, we're taking an extreme cosmic safari to a stellar metropolis hidden deep, deep within our own galaxy. We are pointing our instruments toward a region of space that literally pushes the boundaries of stellar physics. I'm talking about a place of absolute chaotic energy, colliding stellar winds, and giant dying stars. To get there, we're traveling exactly 12,000 light years away from Earth, looking deep into the Orana constellation. Our destination? Westerlund 1. Astronomers widely consider this to be the Milky Way's most massive young star cluster. We're going to peel back the layers of this fascinating region and really get into the extreme forces at play here. Section 1. A hidden cosmic metropolis. And when I say metropolis, I mean Westerlund 1 is an absolute monster, packing up to 100,000 solar masses of incredibly young stars into one very, very tightly packed region. But here is the totally crazy part. Despite being discovered by astronomer Bengt Westerlund way back in 1961, this cluster managed to keep its secrets completely shrouded in darkness for decades. Why? Well, it's because of up to 13 magnitudes of visual extinction. Basically, imagine a thick, impenetrable veil of interstellar dust sitting right between us and Westerlund 1, absorbing almost all of its visible light. You combine that kind of thick dust with severe source confusion because, remember, these stars are packed so incredibly tightly together, and it's pretty easy to see why this cluster was such an enigma for so long. Section 2, piercing the cosmic dust. So, to actually understand this extreme environment, astronomers had to get creative. They used the EWOCS survey, leveraging powerful X-ray and infrared telescopes to look completely beyond the visible light spectrum and pierce right through that thick cosmic veil. And comparing these views reveals a really dramatic transformation. Just take a look on the right. Hubble's infrared vision shows this incredibly crowded, brilliant core shining right through the dust. But then, look over on the left. Chandra's X-ray view totally peels back all that optical confusion to reveal the high-energy, chaotic, and downright violent activity taking place. It's essentially a heat map showing us exactly where the hottest, most explosive events are happening. Section 3. Meet the Wolf-Rayet Titans. Because deep inside this safari, we find a staggering 24 Wolf-Rayet stars. That makes Westerlund 1 the undisputed heavyweight champion of massive clusters, completely blowing past famous rivals like the Arches or quintuplet clusters. So what exactly is a Wolf-Rayet star? Well, these are evolved, extremely massive stars. Think of them as the doomed characters of the universe, living fast and dying young. They've already shed their outer hydrogen layers and are now losing mass at just an astronomical rate, driven by incredibly fast, super dense stellar winds. When you compare them to a standard main sequence star, a Wolf-Rayet star is just terrifyingly extreme. I mean, their stellar winds reach velocities up to 2,000 kilometers per second. And because these winds are so dense and packed with heavier elements, they completely block out soft X-rays. So the takeaway here is that if we're seeing X-rays coming from these stars at all, something incredibly powerful has to be generating them far out in the stellar wind, well away from the star's actual surface. Section 4, a violent binary dance. Because here's the thing, in this cluster, these massive stars rarely act alone. A truly shocking finding from the latest EWOCS X-ray data is that greater than 92% of these Wolf-Rayet stars in Westerlund 1 are locked in binary systems. Let that sink in. In fact, researchers suspect that number might actually hit 100%. This is a game changer because it implies that either all the most massive stars are born in binary pairs from the get-go, or that having a binary partner is actually essential for a star to evolve into a Wolf-Rayet Titan in this kind of extreme environment. Now, how do we know for sure they're binaries? Because we can literally see these cosmic titans wrestling. The massive stellar winds of both stars slam into each other at thousands of kilometers per second. This wind-on-wind collision creates intense shockwaves that heat the plasma up to tens of millions of degrees, generating hard X-rays. And the ultimate smoking gun? The Iron XVX emission line. That is a specific cosmic fingerprint proving without a doubt that we're looking directly at colliding wind binaries. Section 5. Sculpting the interstellar cloud. Now, all this violent energy from these massive stars isn't just trapped between the binary pairs. It's actively generating extreme stellar feedback, literally tearing apart the surrounding environment of the Orion cluster. Just look at these cutting-edge observations from the James Webb Space Telescope's MIRI instrument. They reveal a cluster core filled with a complex, bright, diffuse nebulosity. You are looking at an environment entirely sculpted by extreme stellar feedback. It's the intense radiation and physical winds pushing, carving, and illuminating the gas and dust around these giant stars. And the specific structures JWST found are just mind-blowing. We can actually see what astronomers are calling eastern droplets of gas. They're literally these comet-like shapes of material pointing directly back toward the massive stars, perfectly shaped by those fierce winds. We're also seeing extended shells blown out by the winds of dying red and yellow supergiants, along with these highly directional V-shaped outflows. The entire cluster is just this chaotic, flowing canvas of stellar destruction and creation. Which brings us to Section 6, the impending cosmic fireworks. All of this points to the explosive, inevitable fate of Westerlund 1. Make no mistake, this cluster is a ticking time bomb. Because these massive stars burn through their fuel so incredibly fast, their lifespans are shockingly short. In fact, scientists estimate that up to 65 core collapse supernovas may have already detonated right here within Westerlund 1. That means hiding right there in the dark amidst all those colliding winds and dense dust is a massive unseen graveyard of black holes and neutron stars just waiting to be discovered. So considering the doomed nature of the 24 Wolf-Rayet titans we just explored and the sheer density of massive stars in this cosmic metropolis, we have to leave you with one final thought. With so many stars teetering on the very brink of destruction, how soon until the next star in the Era constellation explodes, lighting up our sky in a spectacular core-collapsed supernova? The extreme cosmic safari is ongoing, and Westerlund 1 is absolutely bound to give us fireworks. Thank you for joining me on this explainer, and keep looking up.